Hello. I still wanted to try to show you a little bit about manipulating the formulas like the acceleration formula, just because describing it is, I know, very difficult to do and then to try to visualize it. So the formula that we're starting with, and I'm skipping past the delta V over delta T version of it, and I'm going straight to that way of writing it. That's the standard way that I want you to look at it, where we've already kind of popped open the top so that it's no longer delta V. It's what it really means, VF minus VI. And this should be your starting point anytime you're doing anything with this formula. Now, let's say, for example, what I was trying to do was the isolation that happens actually quite frequently, solving for VF, because we have a bunch of information about what's happening, and we want to know about the final velocity at the end. So what I can do is multiply this side by t, and what I do to one side, I do to the other. Now, the reason I'm doing that is because even though I want VF, and it's got VI being subtracted, everything is being divided by t. And that screws me up unless I move it first. So by multiplying by t, t on both sides, or on this side, I should say, t over t equals 1. So it just cancels, it goes away. So what I can do is get rid of those parts completely, and I've got a formula that looks like this now. At this stage, what I want to do is now focus on I'm subtracting VI. The opposite of subtracting VI is to add VI to both sides. And sometimes in math class, they write it out this way when they're solving things out in formulas. So that would give me like TA plus VI equals VF. The part that I pointed out is that traditionally speaking, when we're manipulating formulas and isolating stuff, the unknown that we're actually solving for is typically, traditionally, on the left-hand side. There's nothing about this that's actually technically wrong. It's just tradition more than anything. So I'm going to put VF on that side, and then I'll write the other stuff over here. Now, the other thing that I get asked about is, does it always have to be in this order? Well, the main thing on the right-hand side is that the time and the acceleration have to multiply by each other, and then we have to add VI. That's the only stuff that really has to happen. So if you wrote that so that you first showed VI plus AT, that would still be considered correct. And remember the thing that I told you about earlier, it's the reason why we put our little swoopy symbols on our T's, is so that it doesn't look like the addition symbol that we're using there, even if I made this look a little bit more kind of balanced out. We don't want those to be confused, okay? So I can write it as VI plus AT. I could have that back to T times A. That part doesn't matter. All that really counts is these two are getting multiplied, and then together, that's being added to VI. That's really what's going on with this formula. Now, for any other manipulations, it's always the same rules. It's always the same way that we're breaking down what we're doing, and do the opposite math, do it to both sides. That's always going to be true. So one of the other things that I had shown or talked about is, what do I do when I need to solve it for t? I still need to multiply both sides by t, and that way I'm getting that up top, because I can't have it down in the denominator. Then divide by A on both sides. The A over here is gone. And now I'm at the formula T equals VF minus VI, all divided by A. And remember also the warning I gave you that when you're doing any of this on your calculator, the stuff on the top needs to be in its own brackets to keep it together for order of operations. That's it for this section of stuff that I wanted to just show you with doing some quick manipulations. Ask me questions if you need to.